Hello, math students, and welcome to Module 2. We're starting a new module. It is called Arithmetic Operations Including Division of Fractions, and this is Lesson 1. Lesson 1 is called Interpreting Division of a Whole Number by a Fraction. So, our title is Interpreting Division of a Whole Number by a Fraction. And our goal for today we will divide whole numbers by fractions using models. The question that I want you to be thinking about is, what does a fraction do to a whole number? Things to know. So we're going to have a quick review, and when we're talking about the quick review, this is actually a review of something that you probably started learning in 3rd or 4th grade. And the question is, what is 27 divided by 3? And so what I want you to think about in this question is, some of you already know the answer and some of you are already having the answer, but I want you to think about, what does that truly mean? What is 27 divided by 3? So something that we like to do to have a visual idea of what 27 divided by 3 looks like is, you can think of this question, and it says, how many 3's fit in 27? And so what I like to do is I like to visualize, okay, I have 27 cookies, and there's 3 people, and we're all trying to have a fair share amount. And so by having a fair share amount, we need to know how many 3's fit into 27, so we know how many cookies each person gets. That's what I like to think of division as. And so what I'm going to do is I am going to try to determine how many 3's fit in 27. So if I draw 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. So I have 27, let's pretend those are the cookies, and I'm asking how many 3's fit in there. So basically, I'm going to circle all of the 3's that I see. So I see one here, I see another here, I see another here, I see another here, I see another here, another here, another here, I see 3 here, and I see 3 here. So now I can answer the question, how many 3's fit in 27? Well, count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. I know that 9 3's fit in 27. So I would say 9 3's fit in 27. And that's true. So the answer would be 9. So 27 divided by 3 is 9. Now, if you want to go back to exploding dots, how we learned exploding dots with the 10-1 machine. Remember that when we did that? So here's our 10-1 machine here, and we're going 10 to 1, right? And so then what we're looking for is, we're looking for 3's, okay? And if we have 27, we have 2 10's, and we have 7 1's. 2, 3, 4, 5, 6, 7. But what we're trying to figure out is how many 3's fit in there. And so we have to explode this dot, and so that would be over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm sorry that my box is too small. And then I'm going to explode this dot. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I'm going to find groups of 3. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And just like with exploding dots, we came up with 9 3's. Okay, so there's several ways that we can remember what 27 divided by 3 looks like, or figure out how many 3's fit in 27. So again, remember, this is a review. So then we're going to apply what you just did with 27 divided by 3 to another problem. So it says the same question applies to dividing a whole number by a fraction. We just ask how many halves fit in 24, because the question is, what is 24 divided by 1/2? And so we're trying to figure out how many halves fit in 24. So if we draw 24 wholes, right? 2, 3, I'm afraid I'm going to run out of room. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, and let's do 24 right there. And I'm sorry, they're not all the same size. But the question that we're asking is, how many halves fit in 24? Well, these are all wholes. So if we do this, we're cutting them in half, right? So we'll cut all of our 24s in half. And then what we have to do is we have to count how many half pieces fit in 24. So 24 divided by 1/2 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48. And so now we know that the answer is that there are 48 halves in 24. So that wasn't so bad. So if we were to write it as an algorithm, it would look like this. 24 divided by 1/2 equals 48. And the reason why we know that is because we were looking for how many halves fit in 24. Okay, so now let's try the next one. What is 5 divided by 1/3? So remember the pattern. You have to ask yourself, how many thirds fit in 5? So if you're doing the algorithm, we would write it like this. So 5 divided by 1/3. Remember, you're asking yourself how many thirds fit in 5. So again, we're going to draw the picture. 1, 2, 3, 4, 5. And now we're trying to figure out how many thirds fit in them. So we have to actually put our thirds in there, right? Put our thirds in there, put our thirds in there. And now the question that it's asking is saying how many thirds fit in 5? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So the answer would be 15 thirds fit in 5. Okay? How are we feeling about this? Is this starting to feel comfortable for you? And I think if you remember this question, how many of whatever you're looking for fit in the total, then you'll get the answer correct every single time. So we know that 5 divided by 1/3 equals 15 because 15 thirds fit into 5. Okay, and that's how you determine it. Nice job. Okay, so let's look over here. So it says splitting up, and it says I have 8 Snicker bars. 8 Snicker bars. I need to know how many 3/4 pieces are in them. So 8 divided by 3/4 looks like what? Okay, well, we kind of were using tape diagrams before, so let's try that again. So it looks like that we have 8 whole tapes. So 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 full Snicker bars. And the question is, how many 3/4 pieces are in them? So we're asking the question, how many 3/4 fit in 8 Snicker bars? Okay, so this is where it could get a little tricky if you're not paying attention. So the first thing we have to do is we have to divide these into fourths, right? So I'm very carefully taking each Snicker bar and cutting it into fourths, just like this, cutting it into fourths, trying to keep them as equal as possible. And then it says how many 3/4 pieces. So that means that I'm going to go 3 out of the 4, and that would count as 1. So 1, 2, 3. So that's 1. Okay, change colors really quick so that you can see it. I can find my pencil, sorry. So now let's use pencil. So I would go 1, 2, 3. So that's 2. Okay, now let's go again. 1, 2, 3. That's 3. Trade colors again. 1, 2, 3. Again, trade. 1, 2, 3. Good. 1, 2, 3. Okay. 1, 2, 3. 1, 2, 3. Right? 1, 2, 3. 1, 2, 3. And I have those 2 left. So I'm going to show you what that looks like in just a second. So now let's count how many 3/4 fit in 8. So right here is 1, right? Right here is 1. And then this guy right here counts as 2, right? And then 3 would be right here. And then 4 is right here. 5 is right here. 6 is right here. 7 is right here. 8 is right here. 9 is right here. And 10 is right here. So that means that there are 10 full 3/4 pieces. So I would write 10 full 3/4 pieces. And then 2 out of how many do we need to make that a piece? Well, that takes 3 of them to make it a whole, but we only have 2 out of them. So you would say 10 2/3, because we have 2 out of the 3, because see how one thing represents 3 of them? So we have 2 out of our next 3 that we need, so the answer is 10 2/3. Okay? And so doing this on a tape diagram, it makes it very, very clear as to what we're looking for. So it's really handy. Okay? Now, some of you are thinking, okay, well, what if I don't want to draw tape diagrams? Well, that's fine, because we can also do this on a number line. And the number line is very, very similar. So we're going to say this right here is 0. And then we're going to go 1, 2, 3, 4. So that would be 1. 1, 2, 3, 4. So that would be 2. 1, 2, 3, 4. So that would be 3. 1, 2, 3, 4. So that would be 4. 1, 2, 3, 4. So that would be 5. 1, 2, 3, 4. So that would be 6. 1, 2, 3, 4. So that would be 7. 1, 2, 3, 4. So that would be 8. Okay, so I kind of made my number line a little bit bigger than I needed, but that's okay. And then what you do is the same thing we did up here, except you're looking for how many 3/4 make it up. So we would go from 1, 2, 3. So that's 1 right there, right? And then we would go 1, 2, 3. So that's 2. And then we would go 1, 2, 3. That's 3. And then we would go 1, 2, 3. That's 4. And then we would go 1, 2, 3. That's 5. And then we would go 1, 2, 3. That's 6. And then, 1, 2, 3. That's 7. 1, 2, 3. That's 8. 1, 2, 3. That's 9. 1, 2, 3. That's 10. And then look at what we have left over, 2 out of the 3 that we need. And so when you look at it, if I shade this guy in, and this guy in, and this guy in, you're able to see it a little better. This guy in, and this guy in, and then I do the same with this guy. So with this one, this one, this one, this one, and this one, count what we have, and we see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we get an answer of 10, and we have 2 out of the 3 that we need. So again, you would get 10 2/3. So you can use the tape diagrams to help. You can use the exploding dots like we did before. You can use number lines. And so then basically what this whole entire lesson is if you remember to ask yourself how many of whatever you're looking for fit in what you've got. Okay, so this one right here represents what you are looking, right, for, and then this one represents your total, or what you have. Okay, so that's how you remember how to use the question. How many 3/4 fit into 8? How many 3s fit into 27? How many 1/2 fit into 5? And so you have lots of ways to ask that question. That question is really, really crucial to helping you remember how to solve these types of problems. All right, kiddos, so that was pretty simple, wasn't it? So let's go back to our goal of our lesson. Our goal of our lesson today was, today we will divide whole numbers by fractions using models. And that's exactly what we did. Every single problem that we worked on was a whole number, whole number, whole number, whole number, whole number. Every single one of them was a whole number. And outside of the review, every one of the pieces that we were looking for was a fraction. 1/2, 1/3, 3/4. So as you can see, it's very, very simple to using models to help you figure that out. The question that we were supposed to answer throughout the lesson was, what does the fraction do to the whole number? And I would say the answer to that is it breaks it apart into smaller pieces. All right, kiddos, that's all I have for you today. Talk to you soon. Bye.